Welcome to the second day of the 22 US-RSE virtual workshop with a very enthusiastic theme, make it happen towards a diverse and sustainable future. We had a great first day. We are looking forward to an excellent also second day. And yeah, please remember the US-RSE Code of Conduct, and this meeting will be recorded. And so with the Code of Conduct, yeah, be empathetic, respectful, welcoming, friendly, and patient. Be collaborative, and be careful in the words that we all chose. Yeah, and by the way, you know, I'm Sandra Geding. I'm one of the co-chairs, and Julia Damarov, waving in the camera, the co-chair. And with this, I give it to the session chair, Daniel Howard. Thank you so much.
Yep, I'm Daniel Howard. I'll be moderating today. So yeah, please be sure to keep your microphones on mute and video on mute or off during the speakers. If you have a question, feel free to submit them in the chat. Our first speaker today will be Amit Chaurasia. He'll be speaking on, you can go ahead and start sharing your screen. He'll be speaking on supporting collaboration for diverse research and education communities via the Hub0 platform. Amit is a senior visualization scientist at San Diego Supercomputing Center. And so lead the way, Amit.
All right, well, greetings, folks. Welcome to the day 2 of this workshop and to this session. My screen looks okay?
You're all good, Amit.
All right, great. Well, I'm actually pretty excited to present for this particular topic because this is kind of something very near and dear and familiar to the Hub0 team here, the diversity and the sustainability aspect. So this is a very apt kind of topic. And I'd like to share some information around the Hub0 platform and how we go about, supporting different communities. All right, so here is a quick outline for this talk. I need to turn off my video for a moment. Okay, so just a little bit of background. The Hub0 project actually initiated as a follow-on to NanoHub at Purdue University, and over the years it has transformed. But in particular, NSF funded the cyber infrastructure in 2002 to serve the nanotech community. And then when that went underway and it was quite successful, one of the NSF or the advisory board members suggested that it would be great if this platform can be make domain agnostic and serve other communities. And so that's where the Hub0 name was born. And then in 2019, the Hub0 project and the team moved to UCSD. And so this year we are celebrating actually the 20th year for the platform. So this is how the organization sort of looks. Hub0 is a part of the Sustainable Scientific Software Division at the San Diego Supercomputer Center, and we are a part of UC San Diego. Sometimes that's confusing to people because SDSC happens to have a .edu domain name. So we all kind of have seen that we have, pretty exclusive resources in the research community all around the world. And these can be very expensive sometimes. These could be, colliders or supercomputers and many other things, telescopes and things like that. Then we have a lot of content that is produced by researchers and students. We also have a lot of data, software, and a lot of people create them. And we also have an audience for these things. And these could be, scientists, these could be students, and they could be, in broad, the world citizens, if you will. And the idea is that how can these things commingle? In some way, this is the pain point on how to connect the resources and the software and the data and content with people. Right. And so this is kind of a challenging theme which we see occur again and again. And in fact, this is one of the problems which Hub0 tries to solve in its own way. And it's an open source platform which allows research communities to build science gateways or science portals, if you will, where the community can host, software applications, data, or other resources and share them with their communities or groups as they see fit on the same web platform. And while doing so, you make all these connections happening between the resources, people, and the software and data, but also you kind of find a way to measure the impact which is being enabled through the gateway itself, and then also help other researchers to sustain their project and their research. So if we kind of think about Hub Zero in kind of broad categories, we can think of it that, there is a website component where you can brand things and, have kind of a layout and look and feel and all that kind of stuff. And then more important stuff for the research community is sort of what we can call a knowledge center, where you can share publication and other resources. And then how does the community interact and collaborate with each other? That's enabled through forums and things like that. And then, of course, you have the software component and the data component and the resource component, which is all commingled so that people can submit software, others can run that software, access the data, whether that software runs on a local resource, local node, or a HPC cluster. That's all wiring is available. And then more often than not, we see that most research communities always have a custom component. They have very specific needs beyond all these other things that they want to be available to their platform. This could be dashboards, it could be some kind of ingestion scheme or some other automation which the communities are looking for. And so in some ways, these are kind of the broad categories and the ingredients of Hub Zero. However, when the hub is set up for a research community, every hub is unique. They can change the proportion of what these components mean for them and customize them and make it available to their community. And so this mix varies from hub to hub. It's never an even mix, it's always custom. So let's briefly talk about some features of Hub Zero. One of the things which research communities is interested in doing is, sometimes sharing the publications which already exist somewhere with their community. Other times they are also interested in publishing something on the hub itself. And so publications are a part of the Hub Zero platform. Then the community aspect is obviously important, and the application aspect is also important. So let's talk about this in a little bit more detail. So publishing on the hub essentially means that you have a guided way of kind of entering the metadata about the publication, uploading the data or the artifact which is associated with the publication. You can mint a DOI, and then you can assign a license field. There is also kind of a curation system on the hub which can be enabled, which means anytime something is submitted as a publication, it goes to the editor or the moderator who would review that publication and then go back and forth before it gets published. Now, what shape and form this takes varies from hub to hub. Some hub have a very light touch. They just want to make sure that the metadata and the other information is just about right. So, and the publication is good enough to be published. Others can take a little bit more formal view of this peer review process. So again, the capability is there. It's up to the community to decide, or the gateway PIs to decide what makes sense for their hub. And so publications on the hub basically are, in some ways, they are first-class publications. They have a unique identifier and a license and all that kind of stuff. Collaboration is obviously an important component that you want the community to gather around this cyber infrastructure and be able to interact with each other. To enable that sort of interactivity, Hub supports the notion of groups, where you can create a group and invite people and work on projects together. There is also forums that can be enabled in each group, and then there is also a wiki that can be enabled in each group. So it's up to the users and to the community to either create these groups ahead of time or let their members create these groups. And these can have lots of other things embedded in them. And then people can work with each other using these tools. Applications is something which is why actually HubZero was originally created. One of the things which driver was that the professors wanted to teach some simulation software and use the simulation software in classroom setting. However, creating these softwares and making them run on each and every student in '96 was a big hurdle. And so that's how the genesis of HubZero or NanoHub was. And then the idea has kind of broadened up, and the idea is that you can bring your tool, it gets kind of installed in the hub, and then it's available to any user or any group on whatever access level setting that the tool developer that may choose to kind of provide for their tools to be available. So, you know, you can install a variety of tools. You can have, you know, a simple Linux desktop, or you can have a very custom application. It could be compiled application, it could be proprietary application. How it runs is a matter of what the resources needs may be. So if your resource needs are pretty light, they run on a local VM next to the hub, and they can service all these requests very quickly. But if there is a need for doing you know, heavy lifting, there is a way to connect the HPC resources, and then the user basically doesn't have to worry about launching the job. The hub takes care of launching the job, taking the data there and bringing the data back and making it available. And we also have some integration which we have tested on AWS as well. So now let's talk about diverse research communities. And so many hubs are online, and they are available for a variety of disciplines at different institutions in US and beyond. And so here is kind of a list, and if you don't have to scan through this, but if you kind of look at some of these things, you would see there are different disciplines there just by the name of their hubs. And if you kind of look at, you know, what kind of characteristics these each may have, and, you know, we are looking at some of them are modest, others are pretty big. They have, you know, a few hundreds to, you know, few million users every year, all of them unique. They have some modest storage requirements to moderate storage requirements. And, you know, the hubs have been around for a very long time. And so that is an important piece, that it's not just enough to put together these services and software. It's very important to sustain them over long periods of time. And that is something which HubZero project has, you know, done quite well in that regard. So we don't have time for demo, but there are a couple of links which I can share with you. You folks are welcome to kind of click around these now or at a later time to launch an application, look at what the hub looks like. NanoHub is one of the good ones to explore. There is also a hub which we operate for National Cancer Institute. You're welcome to look at that as well. And so let's talk a little bit about how do we work. And so one of the ways where our team works is through, you know, sponsor research projects. Grants are part of the research life cycle. We partner with different communities, be a part of their grant, help them with broader impact, or help them develop new capabilities. Now, grant is not the only mechanism with which people work with us. People sometimes have other avenues of funding, and they come to us for custom application development. And that is also another venue which people have come to us to work with us. The other important component is, again, software development is only one piece of the puzzle. Operations and support is another. And so one of the things which HubZero has kind of refined over the years is the operation model of taking the infrastructure and running it for a community as long as they desire. Now, that's not to say that somebody cannot run a hub by themselves. They can, but there is kind of a scaling issue and some efficiency which we gain because we run so many of these. And I think another thing which is coming up is regulated data. This can be a little bit hard for people to set up, and we do service communities with regulatory requirements such as HIPAA. And we have a way to kind of set up an infrastructure to meet those requirements. Now, most of us come from the software background, and we know a lot of things about hardware, databases, programming, and security, HPC, and so forth. However, all these things are obviously required, but there's more to it. We need more things to kind of go on to sustain these things. And so we need, support from our financial management or project management. We need communications going on through outreach. We need administrative support. We need instructional specialists. And we also need, a way to sustain the business in some way so that we can serve the community over a long period of time. And so the HubZero team has, a small group, I would say, or medium-sized group. We have, about 20 people. And the way we work is, we make their time, the people's time available in slices for other projects if there is a need. And so that way the projects don't really have to find talent for their project and keep them, kind of make sure that we keep them. This is the hardest part in this research infrastructure, to kind of staff a project when you have a grant coming, and how do you continue doing that after the grant is kind of, the grant period is over. So there are a couple of things I would like to request. We will be there at the Gateways Conference in San Diego. We welcome you on if you can make it. Come meet us there. We can talk about HubZero or any other technology thing you are interested in. We are also interested in seeing if there are some unmet needs in your communities or the projects you are working on. Come talk to us. We'd be happy to kind of have a discussion and see if HubZero may be a fit for that sort of thing. And there are a couple other items which we are looking for from the community. We are actually collecting emerging and existing CI requirements from the research community through an interview process through the SGCI program. So if you're willing to participate on that, please, do let me know. I would love to connect you with the right people to kind of get their input. It's especially important that we are kind of, creating new set of software and things like that. All that feedback is going to be very applicable for us. And then we are also recruiting. If you or others are looking for opportunities to work on software development or DevOps, we are recruiting. So with that, there's my contact information. Feel free to get in touch with me, and feel free to explore our website. And happy to field any questions. Not sure how we are doing on time, or dig into more detail. Actually, just about right.
We started a bit late, so we have a couple of minutes still for questions. Feel free to enter in the chat or unmute if you'd like to ask Amit some questions.
All right, looks like the presentation covered quite a bit of it. Or hopefully it did. Yeah, I'm seeing a few messages in the chat. Well, thank you for attending. I don't want to hold the stage here any longer. Okay, Sandra has a question.
Yeah, I have a question. Sorry. I needed a little bit longer to unmute myself. So what is your experience, with the, of course, diversity of fields? How often are there very different aspects in creating, the science gateways for them in that regard with, their data, HubZero instances, there more simulation instances, with the diversity of the different domains? Do you have something like where you say, oh, physics is often in that regard, nano is in that,
Yeah.
Are there typical things? Is the diversity very recognizable between the domains? What is your experience?
I think that's a great question. So I was mentioning that we can think of Hub Zero in 5 different boxes: the website, the publication, the knowledge center, the applications, and then so forth. And each hub's requirements is actually very, very unique. So some examples like NanoHub, their focus started in education, and they wanted to create these tools that they can have a class come in and just go through the exercises of kind of doing all these things on the web. In fact, NanoHub also has something called courses, where the professors can actually create a courses which includes running a simulation. Now, this is very unique, and this has been happening for the last 20+ years. So that's a very powerful way to kind of get your students to kind of simulate something which doesn't require any software setup. So they are focusing on actually using the software rather than kind of doing the infrastructure part of it. So that's one side of things. On the other side of things, some communities like NCI Hub, they are curating a lot of information. They are not right now running any applications. And so they want to make the community submit all these publications and data. So it's kind of a repository-esque angle. So that angle we see quite a bit. But of course, it varies from community to community. Applications, some hubs only are interested in running applications. Like there is a hub called Social Media Macroscope, which basically does analysis of Facebook feeds, and that is fully focused on running applications in a specific kind of discipline or social science domain. So yeah, every hub is very unique, and I think while the infrastructure tends to support many of these things in different forms and fashion, and but there is a very distinct way the people actually use the underlying technology, and we keep extending it. And then whenever we find generality, everything becomes a part of is a part of the software toolkit, and we can just configure and make it available to others as well.
Thank you very much.
All right.
Well, thank you, Amit. Yeah, our next speaker at the moment will be Nasir Isti, with support from Jeffrey Carver as well. Nasir comes from Boise State University, and with collaborator Jeffrey from University of Alabama, and we'll be speaking on a survey of testing research software. Go ahead, Nasir.
Yeah, thanks, Daniel, for the introduction. I don't need to say anything on this slide then. And moving to the next one, you already talked about me. So yeah, I'm an assistant professor at Boise State University, and I graduated with my PhD from University of Alabama, and I'm one of the BSSW fellow. I received the award in 2020, and I also have a little bit of work experience at NCSA and Los Alamos National Lab as summer interns. So what is research software? So this is RSE workshop. I don't need to talk about this. So software quality in research software is very important, because researchers draw insights and make critical decisions based upon the results obtained from research software. So therefore, the correctness of the design and implementation of this software is of utmost importance. And if the software is of low quality, then the results are less trustworthy and prone to failure in mission-critical situations. And low quality software may also lead to incorrect research conclusions. But it is challenging to make the research software error-free because of the complexity of the underlying science, relatively unknown results from the scientific algorithms, and the constantly growing stream of data. So we have also observed that the researchers often place less importance on traditional views of software quality than on other scientific goals. So regarding this impact, so the purpose of this paper was to understand the current state of the art of testing, like how other people are testing the software. So it started a while ago in 2019, before the pandemic. I was in an internship at Los Alamos National Laboratory to develop a testing framework for a research software. So I had some really interesting challenges. So I thought it would be interesting to know how others are testing their research software. So we conducted an online survey. So at first we piloted the survey directly with some experienced research software developers and adjusted the wording according to their suggestions, and just to make everything is clearly understandable. So if you're curious, where did we send the survey? We sent the survey to the Slack channels we have, and any mailing list of research software developers. And also we sent the survey to BSSW newsletter, IDS, ECP, productivity mailing list. So yeah, at the end of the survey, we were able to gather 120 complete responses to include in this survey. And yeah, so I'll be talking about a little bit of demographics. So yeah, there are a bunch of other information in the paper itself. It is published like a month ago. And then you have all the details out there. Just I am here to introduce you the topics out there so that it's beneficial for you to read the paper. For the demographic information, I'll be pretty quick just to let you know what kind of respondents we had during the survey. So this figure shows that respondents were skewed more toward technical roles like developers and architecture than toward non-technical roles. And you know, so we can see that most of the participants had more than a year of experience working in research software, and just under 1/3 had more than 5 years of experience. Close it. And only a small number had less than 1 year of experience. And the project history, the projects represented by the respondents were overwhelmingly in the released state. So this result is important because projects at this stage should have already established testing programs that they deem useful. So we can also see in this figure that most of the respondents worked on smaller teams in terms of the number of developers, that is 1 to 5. So what level of knowledge do research software developers have on software testing? Is there a message for me? Okay, no, sorry. So we asked the respondents in the survey question that how confident are you on your knowledge of software testing? So most of the respondents mentions at least average level of confidence of knowledge of, And then more than 1/3 respondent think that their confidence level is in the range of high and very high. So while we asked their understanding of the testing concepts used in their project, so more than half of the respondents mentioned high or very high level of understanding. Only a few participants mentioned low or very low. And in terms of the understanding of the testing concepts needed, the responses are overwhelmingly in the range of average and high. So now the question is, how do research software developers perform testing? So we asked the respondents about their goals of testing, and the maximum number of participants mentioned level 4, which means testing is a mental discipline that helps all researchers develop higher quality software. And then the second highest number of participants indicated level 1, which means the purpose of testing is to show correctness. And then the next highest level is level 3, which means the purpose of testing is not to prove anything, but to reduce the risk of using the software. Just so you know, level 0 means there is no difference between testing and debugging, and level 2 means, level 2 means the purpose of testing is to show that the software does not work. So this comes from a textbook of software engineering or software testing in particular. Then we asked the respondents about their usage of testing methods. So system testing is the most popular one in research software development. And then a lot of the respondents mentioned unit and integration testing as well. So almost all of the respondents mentioned testing was useful, like always or most of the time. Only a few participants mentioned sometimes or rarely. And then, so why is testing research software difficult? So some of the interesting results are coming up soon. So we asked the respondents that how complex is their testing process. So half of the respondents indicated at least moderately complex to test their project. And 1/3 of the participants mentioned slightly complex. Then we asked them to explain any challenges or barriers they face to test their project. So the most common answer to this question was test case design. because application cases are usually too big or expensive to test. So breaking them down for meaningful system tests is a challenge. And then the second most common answer was lack of resources, which means lack of money, lack of people, and lack of time. And then the next thing is external dependencies, which means research software often depend on external hardware, software, compiler, etc. that makes testing difficult. And because research software developers are not trained software engineers sometimes, so there is always a lack of knowledge. And so here we are talking about research software developers in general. So most of them may not identify them as an RSE. So we expect the RSEs to have a little more interest or knowledge on software engineering concepts. And many respondents found their testing process is very low, but they always have some sort of deadline to finish the task. And there is a cultural difference between the researchers and software engineering community. And one unique challenge research software developers poses regarding testing is comparing with the reality. That means testing ocean model or climate control or nuclear weapons or something like this. And because of the lack of proper knowledge and resources, they may usually have a poor code base, which is hard to test. And many of their code is legacy code. Also, there were a few other challenges. So in this case, we referred the testing methods currently used in commercial and IT software development. So these methods include unit integration, system acceptance, and module testing. So gaining a better understanding of how these methods apply to the testing of research software will help research software developers have more confidence in the methods they can use and reduce the need to discover this information on their own. So we begin with a survey question about the frequency with which respondents use commercial IT testing methods as a team. So as this figure shows, most teams apply these methods at least sometimes. And there are a few teams that apply commercial IT tests rarely or never. And similar to the case when we asked the respondents about the use of commercial IT testing methods personally. So as we can see in this figure, most individuals apply these methods at least sometimes. And there are a few individuals that apply commercial IT tests rarely or never. And beyond whether the respondents use the commercial IT testing methods, we asked the level of value they see personally in using these methods. And so the distribution of the results in this figure shows that the respondents generally saw value in using such methods. So with more than half answering high and very high. And to gain an understanding into where the commercial IT methods cause problems, we asked the respondents to explain any challenges they face in an open-ended manner. So our qualitative analysis of these results identified 9 high-level categories of challenges shows in the figure. So I discussed some of these challenges in detail in the response to the next coming questions. So I'll highlight a subset here. So overwhelmingly, the most common challenge respondents reported was the methods were not useful. So this challenge arises because research software is typically not production software, and some commercial tools do not account for issues with numerical tolerances and things like that. And it is difficult to adapt commercial IT testing methods in the development of scientific software because of numerical errors and other often not knowing the expected output. And similar to the overall difficulties with testing research software, the second most common challenge is to using commercial IT testing method is lack of resources. So one respondent explained the challenges as lack of expertise and schedule demands, or probably lack of R&D or software development oriented tools and things like that. The third most common challenge response is the mindset of the research software developers. So the problem is developers often feel like any time is spent on developing code for the core software is not real work. So thus the time is spent on writing tests is less enjoyable. And in addition, the problem is culture. That means convincing people that it is beneficial, necessary, and worth their time and not insulting to their work. And there are also challenges with mindset that originates external to the team, such as funding agencies are generally not aware of their importance, and effort is spent on testing is not spent on writing, publishing or papers and things like that. So finally, there is a lack of familiarity with the ensemble of testing patterns and goals available. And there is a lack of knowledge, need for infrastructure support, expensive or difficult to use, and runtime restrictions, or that make research software difficult to adopt commercial and IT testing methods. So in addition to the challenges with adopting commercial IT methods, there are cases where those methods are just not applicable. So we asked the respondents to explain any challenges that could not be made by the commercial IT testing methods. The qualitative analysis produced 5 high-level challenges. The most common challenge is by the range of large margin was the methods that do not meet the specific need of research software. So these specific needs include visualization, image processing, analysis, like fluid flow simulation, simulations where there is no analytic solution or known correct answer, that is no oracle. So unique challenge of research software is that validation requires domain expertise, which is sometimes difficult to express in commercial methods. And another situation that is common in research software is whether the results are meaningful. So as I have a few minutes left, okay. So the respondent also mentioned lack of expertise, slow to execute the test, continuous integration issues and benchmarks, and some other challenges that could not be made by the commercial IT testing methods. And finally, the improvements the research software developers thinks they need to bring in. So the respondents mentioned that there is a need for training, such as education, examples, templates, so that they can use proper testing techniques. And they also mentioned they need more types of tests and infrastructure support that will cover specific needs of research software. And another important aspect is acknowledgement for their time and effort spent on testing. Respondents also mentioned to create a culture of testing in the research software developers community that will help improve code quality, continuous integration, and moreover, making the testing process simpler and enough resources can potentially improve the testing process. To wrap up, what I said is overall research software poses a clear goal of testing their project, but the complexity associated with the process needs further attention to make a culture of testing in the research software community, and providing proper training and resources can improve the process in research software development. So in 1 minute, so I got a question. I had a few recommendations, so I can take the question. Okay, so please go ahead.
Hi, my name is Chris. I've been a software engineer and tester specifically for 20 years. What about 2 short questions? And if this gets in the way, then just skip and move along. But what do you mean by commercial testing methods as opposed to other? And the second, did you inquire about the possibility of just seeking engineering support?
Yeah, we have not specifically asked for engineering support. And for the commercial IT testing methods, we use the conventional testing techniques like unit integration, system, module testing, acceptance testing, all that. For example, acceptance testing is not pretty much used in research software because acceptance testing is mostly for users to accept the GUI applications and all that.
Thank you.
Okay. Yeah, next question. Play.
Yes, I was wondering how, if like scientific journals could play a role by requiring testing or evidence of testing upon like submission of a manuscript, or if reviewers could enforce the requirement of testing.
Yeah, that would be wonderful. So oftentimes there are venues like software engineering journals and conference for testing in general, but because this term research software engineering and development is pretty new, I don't see any specific venue we have, particularly for testing research software, but that would be wonderful to have. And yeah, Dan Katz added to JAWS and other software journals ask for testing. So would you, can I ask Dan, so would you accept testing in research software as a topic. For example, I submitted a paper on software engineering conference, and they say it's a good topic, but we don't have enough audience for this. So the paper is well written, but we cannot accept it. So things happen. Yeah. Read.
Oh, do you want to take my question, or do you want to finish your recommendations and then take my question?
I can take your question.
Okay, if you're certain. So I do have a question for you just in general about this. So on the RSE kind of angle, right? So we are seeing a trend towards more research software engineers on research software projects, right?
Mm-hmm.
Do you think this will help with the testing complexity problem, or is it that the tests are complex because the domain is complex, and to what extent could RSEs actually help with that? Like, what's the, I want to know.
So yeah, my study findings says that we need some specific features on the existing tools. For example, handling for numerical tolerances, or more on the floating point issues and all that. Also, the domain knowledge. Sometimes we are testing the science behind it on the algorithms. Mm-hmm. So the current testing tools can only provide the input and output you are going to test, yes or no, or some kind of binary results. But we need some sort of granular level or grayscale of results, like, for example, machine learning results of F1 score and something like that, so that it can compile with the domain knowledge under it. And then I just wanted to say something. I got distracted with the chat message, sorry. And yeah, on the domain knowledge thing is the domain expertise we need. That should be maybe some sort of automation using machine learning incorporated with the testing tools, so that it can at least give us some sort of simulations or grayscale results.
Mm-hmm. Gotcha.
Do I have questions? But I don't know what is happening in the chat. Okay. So if there is no more question, can I go and finish my slides?
Go ahead, Nasir. I'll organize questions for the end.
Okay, yeah. So some of the general recommendations I had, like very in general recommendations, to provide enough training on research, software testing to all kinds of research software developers, ranging from graduate students to experienced researchers, and then incorporate more tests that can solve the specific needs of the research software, providing infrastructure support, for example, a public service of testing, like including many tiers of pricing structure for machine time and sophisticated test dashboard. And yeah. And then provide automation for setting test and analysis of the results, like improve continuous integration system to facilitate a better way of testing, especially the incoming test during downtime. And then make a culture of testing in the team and encourage others by sharing and benefits from the experience of testing, and improve the quality of testing so that the developers can write tests easily. And then improve the quality, yeah. So I think, and some other ones provide proper acknowledgement of developers for contributions in testing, and make the testing process simpler so that it's easy to adopt in the project, and provide enough resources to developers so that they can utilize the resources to develop test suites. And yeah, more questions and time in terms of, so then Gunter has a question.
See if I can get camera. Yeah. So thanks. That was a great talk. I have one question. I don't know if I missed the very beginning of it, honestly, but did you mention sort of existing infrastructure on GitHub? Because for us, that's the sort of default place to go for testing infrastructure, and probably true for a lot of projects.
No, I did not mention anything on that. So are
that
you talking about CI systems?
GitHub Actions.
GitHub Actions,
but other ones that maybe, there's some other alternatives that people use a lot as well.
Yeah, so yeah, we didn't specifically look at this on the responses we get. Yeah, but yeah, that's something very interesting. Especially GitHub Actions are nowadays very popular in the industry, and I think.
Yeah, I find that's I don't know how other people are experiencing that. That solves some of the problems, but I think with, there's always specialized things you need to do or things that take too much resources that it's not going to be very practical for.
Yeah, I agree. So yeah, I can take more questions. Here is my email address. Boy Sister gave me a long email address, but very easy to remember. And yeah, please feel free to reach out to me. And so it was just a step one to gather the current state of the art, and then a lot of exciting research is happening in my research lab. So if you have any questions, so feel free to reach out to me or Jeff Carver. So we have 3 participants raised hand. Okay. So if we have time, we can go on and on. Yeah. So Daniel,
Let's go with Reed first, because I'm not sure who had the hand raised first, but go ahead, Reed.
Oh, sorry, my hand was still raised. I'd already asked the
yeah,
question.
so I realized that.
Yeah, I had the same problem.
Oh, okay. Well, I had one question from your recommendations. You were mentioning sharing people's success stories with testing and such. I'm curious, like both, I guess, 2 questions in one maybe. Within the survey, if there was a collection of success stories and say outcomes of like say well-integrated testing within research software workflows, and how that correlates to say improved outcomes. And then through that recommendation you gave, like which are there specific success stories that you would specifically share with the community here to encourage adoption of like testing within their workflows?
So we are working on a follow-up survey on this. So I hope to have some results from that survey on the success stories. I think that would be very wonderful addition to come to a community talk or a workshop to speak about. For now, I can tell about what I did on Los Alamos National Laboratory. So we had a non-deterministic software project that produced different results every time. So we were really trying to use any of the commerciality methods or I mean conventional testing techniques to apply on it. But during the time frame we had, so finally we had to do any statistical testing. So that was kind of new in software testing, because you don't usually use a statistical test on that. For example, we used multinomial testing to, and then we hacked the molecular dynamics engine behind, and we build our own Markov chain molecular engine for that. So that's the science part of it. And then we were able to run multinomial test to get some yes, no, or binary results based on the p-values we received. So I would say that is a success story, and I had published a paper on that. So that's the title is Testing Research Software, a Case Study. So you may want to read it. So you may have similar, so many of you may have the similar scenarios where you cannot apply. And then on that paper, I described like which methods we wanted to use, for example, metamorphic testing and or runtime assertions or things like that, but why we were not able to use that given the restrictions we had on the systems and all that, and why we had to hack the backend engine and then finally able to test the outputs and all that. So that is a success story. And I would love to know more of success stories too. David?
Thanks, Nasir. Yeah, I just wanted to ask, and you might have covered this and I just missed it. Are you thinking about maybe dividing things up into a researcher who has an analysis and wants to test that compared to a research software engineer who's testing a framework or a whole system? And I just asked because we just got a submission at PyOpenSci of this package. It's test-driven data analysis. And they're basically like trying to map this idea of test-driven development onto your like analysis pipeline. So I feel like some people are thinking about this, but I don't know how much thinking's been done about it.
Yeah, but I would say you gave me a very good suggestion for future work. Yeah, thank you for that. Yeah, definitely it would be interesting to know on this. Yeah. For now, I don't have anything analyzed like that, but that sounds very interesting.
Thanks. I'll look for the future work.
Mm-hmm.
Yes, our next speaker is Daniel Gunter. He's coming to us from the Scientific Data Division at Lawrence Berkeley National Lab. He'll be speaking today on including UI and UX in the RSE community. So go ahead, Dan.
So I actually prepared this with Lavanya Ramakrishnan, who's our deputy division director now in the scientific data division, and both of us have done a lot of work with user interfaces and user experience. And so I wanted to talk about how I think that can be incorporated with the good things that everyone does here. As soon as I figure out how to advance the slide, there we go. So I wanted to start by saying that I'll just make the statement now, and hopefully this, if you don't believe it, it gets a little bit proven as I go along, but user interfaces are important for research software in general. And for some of the same reasons, really, that user interfaces are important for software that's not research software. They make complex tasks simpler or possible and provide visualizations and visual controls that encourage experimentation. I would say that more on the research software side, they enable understanding of groups and communities that are outside the researcher's experience and become a bridge to broader applications of the research results, which is, I'll note, a function that's not typically served by academic publications, which tend to be more targeted at people who already understand exactly, the details of the research results. And when I say user interfaces, by the way, most of what I'm going to show is graphical, but really it could apply to graphical or application programming interfaces, command line interfaces, or something else. So the kind of commonality is that in the research domain, I think designing user interfaces is really designing for expert use. And that's kind of probably the key difference that you'll see across a lot of these projects with things that you see in commercial applications. So before diving in a little further, I'd like to kind of define like what I mean by UI and UX roles. And before doing that, I'll also say that I know that a lot of user interface development is kind of not done by people who would say that's what I do all the time. It's kind of it's development as part of I have to do this in order to get my work done or do something else that I meant to do already. It's kind of accidental. People are thrown into it. And guess I can relate. The very first thing I did at Berkeley Lab myself, but way back when, we used 2 sticks and rubbed them together to make fire, was when I was first an intern at the lab. That I showed up kind of day one, and they sat me in front of my giant CRT screen and said, "Hey, we've got a user interface here that the previous intern kind of left half done. Can you finish it? And here's a Tickle TK app, and by the way, we hate the color scheme. Can you fix that as well?" And that was my introduction to being a user interface developer. So I think that kind of accidental experience is, if not in detail, but in some aspect, common across a lot of people. But there are also a lot of people who define themselves by doing a lot of particular UI and UX roles. And that's true in my group and a lot of other groups, I think, at the labs. And there are different kinds of UI and UX roles. And I'm going to kind of give them in the order, I would say, of the order in which they kind of occur in the development of a project. So the user researcher is someone who goes out and takes initial ideas and prototypes and talks to users. That's what the performing user research really means, or solicits feedback through things like surveys to sort of understand what the problem space really is. Then there's user experience designers who will design the workflow of the application, get feedback on working versions, and to fix design problems and get ideas for how the features work. Then graphical designers, this is a role that's often subsumed, as part of another one that people have, was rarely something you have at the national labs as a sole description. But graphical designer will create the look and feel of the user interface. So do things like choosing colors, fonts, graphics, making layout decisions. And then finally, the user interface developer is the role that would write the JavaScript or HTML and create documentation, deploy the software. And of course, these are kind of hats, really, that sometimes are worn. One person may wear many of these hats. Some people may wear one primarily. But it's important to kind of understand that there are different roles involved in the creation of the user interfaces and understanding how to make good user interfaces. So I want to walk through a couple examples to sort of ground this discussion a bit, and starting with the point that In our work, we have really come to the point where we take a kind of a dual approach to scientific and engineering software, which is, Berkeley Lab, what I would describe as what we do. And that we take user research, which sort of sits at the center between the users and the R&D team. And we use that as a process to validate the intuition about what the user needs and convert that into action. So sort of the user experience designer essentially becomes the center of those two circles between understanding the science needs and actually implementing all the system software and tools on the back end. So I'll give a couple of examples of some projects I've been in and why, this has convinced me that user interfaces are really important. So the first one is the materials project. This is a pretty popular in the materials science community, web-based and also other API-based interface for getting at state-of-the-art computations for materials, particularly bulk solids, but I believe they have some more in there now as well. Metal organic frameworks, et cetera. And really, the genesis of the project was to make these state-of-the-art computations available to the broader community. So it was a little unusual in that in the material science community that from the very beginning, they emphasized user interface because they knew getting to experimentalists and people outside their domain of theory was going to require something that was more friendly. And the UI was really essential for making this data visible and accessible. So I was a small part of this project, but I think I'm not going to take a lot of credit for the kind of the immense success that it's had. I think I just showed this bottom graph to show how well this particular website has succeeded. That number there, this is a chart of the users per month over time, and that number is 100,000. So that's a fair number of users for a material science application in particular that are really getting some use out of this user interface. Another example I'll give is one where you can see that the user experience approach has really been useful in revealing underlying workflows. And this happened some time ago on a project called the Nearby Supernova Factory, or SN Factory, where they had an interface to their data. And it was kind of a search interface that they had to the data system. And the user experience expert went in and talked to them and tried to understand their problem. And what they found was that they had a bunch of notebooks that they were using on the side to actually track what was going on with all these supernova discoveries that the system was finding, that they weren't using, that the system wasn't actually helping them with at all. And what they need, so they had a search interface, but what they really needed was a tracking system that took the place of and improved what they were actually doing on the side with their notebooks. So it's that kind of insight that you really get from starting with the user experience view of this. And then finally, I'll talk about, there's a recent project we have called Pareto, which stands for, well, it's not too important what it stands for. The important part is that it's bringing the power of mathematical optimization to a domain. It's called produced water. And for those of you who've never heard that phrase, like I hadn't, that means basically water that comes out of things like the oil and gas industry that's not potable, but could be processed to be used in other ways instead of just dumped back down into a hole in the ground. Which is actually, and I won't go into it, but is actually a major problem. So in this case, the main point is that UI and UX are a really important bridge between the researchers who have these optimization models that are able to come up with better solutions and the actual community that needs to implement it, because those people are not, the end users don't know anything about optimization models. They know a lot about how their system works, but not about how the model works. And there needs to be a bridge between the two. And that's where UI and UX can figure out what that bridge should be, understand how the users want to use the software. And in this project, for example, the software to some extent is ready to roll, but they can't really release it until the user interface is at the point where users can use it, because that's the only way they're really going to be able to understand how to work with this code. So those are some examples of some projects that UI and UX was sort of featured on. We've also doing some research on user interfaces and user experience. So in our research environment, because having worked on a number of these projects, you begin to see similarities across the science domains and the science applications. And you wonder if there's something better we can do to make this process of designing these workflows more consistent, more efficient, and et cetera. And so this is a research project that's recently been funded from the Sloan Foundation, where we're going to be asking these questions about if we can have a typology that can characterize better in a more abstract way than just anecdotally all the different things that are going into these different workflows. And can we come up with a design system or a design framework that can simplify the design of these user interfaces and make it easier for things to be more intuitive for the users. So there is some research to be done as well, and RSEs would play a role, both on both sides of the fence there. So I've gone pretty quickly because I kind of wanted to get to this main slide. This is sort of the end game in my presentation. And hopefully there's a few questions and comments people have that we can spend time on after I'm done here. But it's because I think that right now, the user experience and user interface perspective is a little bit less visible than it could be. And I think that actually making it more visible and more prominent and including more people from those sides of the community will help improve the diversity and inclusion across the board, because I think user experience and user research tends to ask the right questions, which is what do people, in this case users, really need, and what people or practices are we not addressing? It's questions like that that we need to be asking to keep building the community as well. And of course, it's not a coincidence, because you're trying to build a community to use the software, right? So it's some of the same goals, just in a different context. And so I think those are kind of the right skill sets and the right experience sets to be including to help expand the RSE community. And so if you accept that, if we have that in mind, I would say that we have an opportunity to kind of do a few things to include UX and UI more fully in the community. One would be to examine some current definitions that we tend to have out there of RSEs with a bit of a critical eye. Even though this seems like a very minor thing, I think these do matter, and that when you see wording or descriptions of something that you don't feel includes you, there's less of a tendency for you to say, well, I want to be part of this, right? So when we have definitions that sort of exclusively focus on expertise in programming for the definition of an RSE, I think that's a little bit exclusive, not just of UI and UX, by the way, but of probably some other groups. So we should keep an eye on that. But also sort of more constructive forward things to do would be looking for more representation opportunities for UX and UI. For instance, topics at meetings and workshops, case studies that get documented on web pages, considerations when you talk about RSE and careers and impact. Think, we're including anyone who's doing user interfaces or user research. We could probably start a channel, and then this is something that anyone could do. So it's on me as much as anyone to start a channel in US-RSE Slack, or include a working group that's somewhat specific to user research and user interfaces in the US-RSE organization. And the other thing that comes to mind that I'd like to mention at this point, there might be some other groups that might also be on the margins that we're not thinking about as much as we should. So what come off the top of my head more or less was that DevOps, people who work on documentation. I actually have one person in my group who describes themselves as a documentarian. So there are people who do enough documentation that that's a major part of their job. And there's actually, of course, an industry that's a job description. And then user support, right? People who kind of exclusively interact with users. And to some extent, even some of the manager level people could describe themselves this way. Are other people that might be somewhat on the margins. And again, if you look back at that sort of straw man definition, not quite as well covered by that. So that's my talk. That's my overview. I just ready. I don't know if I gave myself, did. Thank you. And I always try to end early on talks. So I would be happy to take any questions. I see there's something in the chat, which I wasn't able to. Oh, is there time for questions?
Yeah, there's definitely time for questions, Dan. Feel free to raise your hand and unmute or enter your question in the chat. We'll be happy to field them.
Okay, will you call on people or should I?
Go ahead, Ian. I think Ian has his hand first.
Hey, thanks, Dan. I kind of want to maybe echo or endorse. I've seen in my group a lot more requests for this type of making my research accessible through some kind of, interface or website or, some way more than a command line or a downloadable package. So I think, and I've seen this uptick in like the last couple years really taking off. So I think you're right to kind of bring attention to it. And so maybe this is less of a question, more of a, US-RSE is a great place to do this. And we're trying to talk about these ideas of affinity groups. So people who work on similar type things of getting together and building a sub community. So rather than a working group where you're trying to produce something, an affinity group where you get together and discuss issues that you're seeing, that you're interacting with, that you're, tools, technologies, tips, tricks, and building a sub community. So because I think it is a growing subgroup. So I guess that's just a big endorsement rather than a question.
I think that's a great idea. Affinity groups. That's a much better way to put it. Yeah, that's a good idea.
Go ahead, Aaron. You're next.
Cool. Hey, thanks for the talk. That was pretty cool. So I'm just kind of curious at a really high level. One of the things that I do here is try to take industry ideas and apply them to RSE work. So I'm a big proponent of domain-driven design, for example, sit down with clients and figure out like their exact domains and use cases and whatnot and kind of go from there. But I'm curious what sort of techniques and methodologies you apply to the design of APIs and UI, UX, and so on and so forth.
I think we try to emulate some of the things that are done in industry, which is so what I think is most effective is talking with domain experts to start with to get it. You have to get some background before you can start going out and talking with people. Otherwise, you seem like you're asking questions that are so far off the beaten track. But then with some background in hand, having something that people can look at, like a prototype or anything. It could actually, I've done it with pieces of paper with sketches on them. They need something to look at before they believe you. And it can't be so good that they believe it's already implemented. And then talking with people in very small groups, 1 or 2 researchers with 1 person, and walking through what do you actually do to get your job done. I think that may be exactly what you're describing, by the way, is probably the primary method of prioritizing and understanding work processes, because I find that in a larger group, people are often reluctant to talk about things that they consider one-off or backwards ways that they do things, but that are actually the real way that they do things, right? And so it has to be a smaller group. So that's one of the tricks, and of course, looking for diversity of people that you talk to is always really important.
Cool, thank you. Yeah, one thing that we're about to try, you're definitely right that some people are reluctant to speak up in larger groups. So we're going to try event storming, where people don't really talk, but they put their ideas down on Post-its and we kind of reorganize things. And yeah, it definitely seems like a pretty cool and useful idea, but we'll see how that works out.
That'll be, I'd love to hear about that. Yeah. I mean, I found a lot of the best insights have actually come from things we didn't ask, but things that people, after they got a little comfortable, would just sort of, we didn't script it. It just, oh, by the way, it's like, oh, that by the way was something that was more important than any question I had. So, yeah.
Thanks, appreciate the input.
Thank you.
Well, thank you, Dan. I think we have to move on to the next speaker. So our next speaker is Blaine Moores. He comes to us from Oklahoma City and the University of Oklahoma Health Sciences Center. He'll be presenting on the virtual Oklahoma Data Science Workshop. So go ahead, Blaine.
Thank you very much for the opportunity to talk about this data science workshop that we have set up. And thanks to the pandemic, we have tried to make it statewide. So I'm a domain scientist. I'm a biochemist, and in a college of medicine. Sorry about that. So this is the where I work at the University of Oklahoma Health Sciences Center in Oklahoma City. This is a view of our campus taken in the early fall. You can see some of the maples turning red, looking out towards the west near sunset, towards the very flat rolling plains to the west. But to the east of us, we have wooded hills. And I work in a basic science department. There are 5 of them on our campus. And in the College of Medicine, we have about 20 clinical departments. And on this campus, we have about 10,000 employees that show up every day. I'm located in this building where I have a research lab next to a core facility for X-ray crystallography. So I probably have, I thought I should explain a little bit the context I'm coming from. So we crystallize biomolecules like proteins and RNA, and then we put them in an X-ray diffraction instrument, collect diffraction patterns, determine electron density maps, and fit models to them. This is the crystal structure of RET kinase, a protein that's important in lung cancer, with a drug that was just approved by the FDA for treatment of lung cancer. So that's an example of the kind of projects I work on. We are able to optimize cryo conditions in-house, and then we send our crystals off to a national lab. So I'm a user of national labs, and I have made use of all 5 of the national light sources in the US, but I use SSRL heavily. I've been a user since 1999. I've traveled there probably 60 times, generally about 3 times a year. And I've started to pay back by serving as on the SSRL User Executive Committee. This is a committee of about 20 people representing different domains of science amongst the users of SSRL. And these light sources hold every year an annual meeting in which there are actually many RCE type topics that are discussed. This is from the meeting in 2016. At the time, I was vice chair of this committee, and I was organizing this meeting with the vice chair of the LCLS User Executive Committee. So the LCLS is a free electron laser source that is also at SLAC. So SLAC is unique in that it has 2 light sources on its campus. The following year, I became chairman, and we had a problem. The funding for SSRL was cut, and in the president's budget. So we mobilized 4,000 current and past users to push back. We lobbied Congress, and we got funding restored. But in the meantime, that caused a lot of damage. We lost 2 senior research software engineers who decided that all the instability was too much. They obtained jobs in Europe, and they're not coming back. So SSRL really hasn't recovered from that event. The funding has been flat over the past decade, and they've really been hurting this year with inflation. But after this, the trauma of this year, things kind of, well, at least I got to share that experience the following year on a discussion panel at the Society for Science at User Research Facilities, which probably has some overlap with this group. Then after attending these user meetings for over half dozen years, it dawned on me that it might be useful to hold a workshop that was focused on computational methods. And so in 2020, I started doing so. This is an image showing the portraits of 8 speakers that we had last year in this workshop. And we'll have, next week we'll have, or in 2 weeks, we'll have our 3rd version of this workshop. We managed to have gender balance last year with 4 male and 4 female speakers, and also a good distribution of ages, with 1 speaker being a graduate student at MIT probably in her mid to late 20s, and another speaker being in the early 70s, David Case from Rutgers University. So what's my role with software? I'm over the past dozen years, I've been picking up Python. I've developed a number of Python functions to make it easier for my students to use Python or to use PyMol. So they don't have to know Python. All they have to do is be able to enter a few shortcuts or aliases to functions that do things like generate molecular representations that are not available through the GUI in PyMol, which is a very popular molecular graphics program, has over 100,000 users. So I've published some related software packages, and I find myself getting more and more into software. So I'm expected, of course, to use as a user, not a developer, the standard structural biology software, which is very user-friendly, and you can do a lot of this work through just using a GUI interface and not really having to know much about programming. But I have picked up some skills over the years in various areas. I did learn Fortran way back in the early 90s, and I'm glad to, yeah. Obviously, I made the comment about it being around in 2090 on Wednesday. And I also use supercomputing facilities. So I'm the only person in my department. I feel incredibly alone and isolated. And I was looking around for a group to belong to. And I found this group on my campus in the opposite end of the campus. It had been going on for 4 years before I found out about it. And this is a GitHub page that shows, has all the presentations up to the start of the pandemic. They're focused on statistical computing, and they tolerated my presence. They allowed me to talk about using Python to do Bayesian data analysis a couple of times, but it was a little awkward talking to our users about Python. So I decided to form a group focused on Python, which initially we wound up calling the Python Workshop. So our goal was just initially to provide a platform for talking about scientific computing. We have a problem in that we have a graduate program in basic science. Our students take courses the first year, maybe part of the first half of the second year. There are no courses available in programming. And often our students discover in the third or fourth year that, wow, I do need to know something about programming, and it's like essentially too late. And then we don't have a computing center that supports basic science. We have one that supports clinical research, and we don't have support for Mac and Linux-based computing because our IT is very focused on supporting Windows operating systems in the clinical environment, and that's probably pretty universal, I think, on medical campuses. So we got, I got together with some bioinformaticists at a neighboring institution that, just across the street at the Oklahoma Medical Research Foundation. And we put together this Python workshop. Had our first meeting in January 2019. We met in person. We met in a small room, 25 people, nice and intimate. We had everyone really enjoyed the sense of belonging. So we set it up by having a series of talks by members of the group. And that went on for about 1.5 years. And then the pandemic hit, and we wound up having to make a transition. But we did, after about first half year, we moved to a larger room where we could record the talks. We had many people who were interested in attending, but they could not because of schedule conflicts. And by making the videos available online, that helped a lot. We've had some of our videos have had up to 80 views by local people. And this was support for this was provided by our Vice Provost of Faculty Development. So we had this interruption of a half year, a hiatus due to the pandemic, in the first year of the pandemic. And then in December, well, over Christmas break, we started discussing changing the name and going virtual and increasing the scope to include institutions from around the state to try to draw in additional talent and in terms of speakers and as well as attendees. And so we have now a mailing list of 180 people. We have, and we started out with about 20, 25 participants in our Python workshop in contrast. And we have all these institutions participating. We have monthly meetings year round. And the management of this costs about somebody 100 hours of effort a year in terms of all the emailing and so forth, sending out announcements, lining up speakers. There's a oversight committee, our steering committee, and so we just meet on ad hoc basis to discuss issues that come up, like changing the name of this group. And these are the topics that have been covered. We have 26 videos now online, and you can see that they are very broad in terms of scope. We do have a few talks that are domain specific. One limitation of making the videos available online is that people are very reluctant to talk about unpublished research. So you know, it's hard to win everything all at once. So what would we like to be able to do that we've had trouble, we haven't been able to do due to lack of time or resources or because of the pandemic? It'd be great to be able to have a symposium on scientific computing. It'd be great to have a series of maybe day-long or half-day workshops on Saturdays when PIs would not be upset about their graduate students attending these sessions on Python, just going through what pretty much the content of a regular course, going over the basics, or likewise for R. There's been discussions of having hackathons. Everybody would like to do that, but nobody really volunteers to come up with that, putting that together. And likewise, maybe setting up a regularly based drop-in office hours where somebody with a computing problem, where they need help or stuck, they've been stuck for several weeks, they could come in and talk to people with more expertise. So my observations are that academics are extremely overcommitted. There was a mention on Wednesday about how getting undergrads involved, you can't have very high expectations because they're not being paid and they're busy doing other things. Well, the situation's even worse with faculty members. And so you really have to keep, in this kind of environment, your expectations very low. And I think it's really important to match your mission with the time and the energy that's available. So we've been able to keep this thing going for 4 years with this very, very modest mission of providing a platform where people can talk about scientific computing. I've been really impressed by how people really follow through on their commitment to give a talk. We've never had anybody back out. And but on the flip side, nobody wants to do the organizing work. They rather have somebody else do it. And I think we have 180 people, but the attendance is averages about 20. We've had a range from like 8 to 35, and I think that is a lot of people are on the mailing list due to the fear of missing out, and we have a very large turnover in the attendance. There's always a kind of core group of people that show up at every meeting, but they make up maybe 30%. And then the remaining 70% are people who are showing up because they're interested in the topic that's being presented. So the meetings consist of somebody who wants to share their insights or their new knowledge about software package. In my case, I've talked about like parallel computing in Jupyter. I've talked about using Jupyter supercomputers, things like that. Things are not really specific to my research per se. But that would be of general interest. So I'd like to thank Valerie Williams, our Vice Provost of Faculty Development, for providing the support for getting these videos recorded and posted online. And I'd like to thank Melissa Nestor, she was a member of the Statistical Computing Users Group who went along and joined the Python Users Group. She's not a PhD scientist. She works in IT, and she managed to facilitate the handling of our Zoom account, and so that we could have one for a large number of people and for people off campus. I'd like to thank William Beasley, who ran the Statistical Computing Users Group and provided the inspiration for our group. And I'd like to thank Jonathan Wren at OMRF, who's a bioinformaticist, whose students pretty much supplied maybe about half the talks that have been presented. So he's been extremely supportive of this effort. And then I have my funding sources. So I'll be happy to take any questions.
Thanks, Blaine. If you have any questions, feel free to enter them in the chat or feel free to raise your hand and unmute.
Oh, great. Some questions. Fantastic.
Yeah, I was wondering, was it challenging to get I think you mentioned like the vice provost was part of like supporting this like effort. Was it challenging to get like them on board with this?
Well, I have to provide a little history. So she puts on a faculty leadership program, and I had attended her program about a decade earlier. And so she's already sort of predisposed to try to help me out. I wrote a page-long letter describing in detail how this would benefit the mission, educational mission of the university. And so we're feeling a need for graduate students to have a platform to talk about using computing in their research. And there wasn't such a platform. So she bought into that need and decided to support it. Thank you.
It sounds like you like added a whole bunch of value. So awesome talk.
Thank you.
I have a question as well. I guess it's laid on the same note. So it sounds like you've built out some very successful communities in this space, particularly in the health sciences. And I'm curious in seeing, say, like the diverse participation in some of the events you've coordinated and helped put together. What would you say are some like best practices from your end in terms of like bringing people into the fold and like actually being willing to accommodate and allowing for and encouraging people across varying identities and groups to come in and participate in these training sessions, conferences, etc. Effectively, because you mentioned like varies across age, across gender, and I'm just curious your thoughts in terms of being able to successfully do that so far.
So with regards to like the SSRL users meeting, I have been totally amazed that if you invite somebody to like give a talk, it's extremely rare that they turn you down. So it's just simply a matter of asking many times. In terms of getting better participation from the local community for our data science workshop, that is that's a problem for us. And so some semesters we will start the semester with an empty agenda, and it will take some effort to get people to volunteer. So I definitely, I think I've learned a few things at this meeting about how I might strive to be more inclusive and reach out to groups that are not represented yet. So for example, we've been quite Oklahoma City centered, and we've had trouble pulling in people from OSU and OU, which are located from a half hour to an hour and a half away from Oklahoma City. And we've had just a few people recently. But we've also, one thing that's helping us is that we have a data science institute on our main campus in Norman, half hour south of us. And they, to try to achieve some of their missions of outreach, they have put forward some speakers this fall semester. And so we're, by doing so, we're both achieving our objectives. So I hope to couple our workshop more with them in the future. We have, for example, we have some historically Black college. I haven't gotten a participant from there yet. I've reached out a few times, but I have to figure out another new way of reaching out. And there's some, we do have participants from a university, Northeastern State University in Tahlequah, where 25% of the students are Native American. And so we have yet though to recruit a speaker from them. So we have a lot of opportunity, I think, to make it our group, our presentations more diverse. That's for sure.
Thanks, Blaine. I think that sums up a good response to that question there. I appreciate it. I believe we're out of time now at this point. So let's thank again our speakers today. If you'd like to follow up with any of them, feel free to follow up over email, or as well, you can also join the RSE Slack space, and I'm sure that they'll be happy to facilitate further conversation there, as has already happened throughout the day. So I think I'll pass it off to Ian or Julia for outros.
Yes, thank you, Dan. All right, well, thank you, everybody. Thanks for our technical programming chair, Richard Abdel and Mahmoud Chad. Thanks for our session moderators, Daniel Howard and Daniel Katz. Thanks to all the reviewers. Thanks to all the authors that submitted something. Thank you to all the presenters. And thank you to all the participants. Thank you for making this a success. I think it was a really good workshop. And I learned a lot, and it was very interesting talks. We are planning an in-person conference next year, so I hope that many will join us there, and stay tuned for updates.